volcanogenic massive sulfide deposits, commonly known as VMS, and sedimentary exhalative deposits, or SEDEX for short, are both stratiform sulfide mineral deposits. However, they differ in their geologic setting, formation processes, and typical metal content. VMS deposits form in submarine volcanic environments like mid-ocean ridges, back arc basins, and volcanic arcs, and they are always associated with volcanic rocks, typically basalts to rhyolites. VMS deposits occur as a result of underwater volcanic eruptions that take place along a rift or spreading center that is created by extensional faulting of the rocks that make up the seafloor. The extensional faulting is caused by magmatic vortices in the Earth's liquid outer core that put an enormous amount of stress on the crust, causing it to break. Magma from the Earth's interior exploits extensional faults and oozes out onto the seafloor. These eruptions create negative pressure, causing seawater to be drawn through the surrounding mouths and underlying rocks as it makes its way toward the base of the volcano. Along the way, this water dissolves minerals within these mouths, rocks, and magma, becoming a mineral-rich hydrothermal fluid. The dissolved minerals include copper, gold, lead, zinc, silver, and other elements, such as sulfur. These mineral-rich fluids are heated as they are drawn near the magma deep below the volcano. As these mineral-bearing fluids rise upward, they encounter the volcanic pile, getting trapped in cracks and voids within it. Some of the more energetic fluids escape the pile and form vents known as black smokers, while other fluids are ejected from the volcano. As the hydrothermal fluids cool and encounter changes in chemistry within the volcanic pile and in the seawater, they begin to drop out the dissolved metals. VMS deposits often have massive to banded textures, and they can also include a stockwork feeder zone beneath the deposit. Common metals found in such deposits are copper, zinc, gold, and silver. As for sedimentary exhalative or SEDEX deposits, they form as a result of the venting of a mineral-rich brine into sea basins. This type of deposition occurred in ancient sea basins up to 2 billion years ago and is still occurring to this day. This venting is an outcome of extensional faulting in the rocks that make up the seafloor. Extensional faulting is caused by magmatic vortices in the Earth's liquid outer core, putting a tremendous amount of stress on the rocks that constitute the Earth's crust, causing it to separate. The separation of the Earth's crust causes a depression to form in the seabed called a graben, and the extensional faulting provides an escape route for the heat of the Earth's interior, therefore establishing a venting process along the fault. This venting causes the seawater to be drawn through the surrounding mouths as it makes its way towards the intake of the vent. Along the way, this water dissolves minerals within these mouths, becoming a mineral-rich brine. The metals dissolved within this brine are largely iron, but also lead, zinc, and silver, and other minerals such as sulfur. This mineral-rich brine is ejected by the vent into the surrounding seawater. The brine chemically reacts with the seawater, causing the dissolved minerals to precipitate out of the solution and settle to the seafloor. The graben caused by the extensional faulting that gave rise to the venting in the first place now acts as a depression for some of these metals to accumulate. This occurs over a long period of time, perhaps hundreds or even thousands of years, during a relatively quiet period of tectonic activity in the region. When this quiet period ends, marked by an increase in earthquakes due to tectonic activity, large amounts of sediments enter the basin, blanketing the seafloor, causing the venting to cease. SEDEX deposits are distinguished by thin, laterally extensive layers or lenses of sulfides, and they are often fine-grained with a more sedimentary-like appearance compared to VMS deposits. Common metals exist in SEDEX deposits are zinc, lead, and silver, and generally they are low in copper, unlike VMS deposits. And as it's always the case with almost all magmatic and hydrothermal deposits, an uplift process due to continental collision eventually moves these deposits and their host rocks upward, where they are exposed to weathering and erosion.